Okay, so today's topic gonna be, see, we have already done with statistics. Okay, so we learned about the dispersion, uh, measure of central tendency, basics, right? In statistics, how statistics is used to do a first level of uh, analysis with your data, right? So similarly, we have something called EDA. This is very core EDA. Okay, in short, it is called EDA, and the full form is Exploratory Data Analysis. Okay, for any data science job, you need to know this. Okay, this is the basics that everybody does with the basics data analysis, whatever the data you have. So what is EDA? Okay, EDA stands for Exploratory Data Analysis, and it's a process of analyzing and summarizing data. Okay, analyzing and summarizing data to what? To uncover patterns, trends, relationship, anomalies, and insights about your data. Okay, these are the 5 points you have to remember: patterns, trends, relationship, anomalies, insight. Okay, so today we're going to do the basic uh, theoretical class today. Okay, so what we're going to do is from tomorrow we're going to get some hands-on on these topics, and then we will go to solve some of the data sets from various domains. Okay, like healthcare domain, sports, entertainment, then uh, telecommunication, HR, and so on. Okay, if you get some hands-on with the different data sets, then whatever data that you are working currently, okay, it will help you to narrow down and get the results faster. Okay, so exploratory data analysis is the process of analyzing and summarizing data sets to uncover the patterns, trends, uh, anomalies, relationship, and insights. Okay, and also we called it as it is the first step. Okay, it is the first step. Okay, after collecting data, say for example you have a data set. Okay, so for example you guys are a data scientist and you are a consultant. Okay, so I'll share the data. Okay, support data. Okay, ticket data. Okay, so I'll hand it over to you. Okay, and then you have to start working. You have to do your EDA, exploratory data analysis. Okay, so that is why it is called the first step after collecting data and before applying statistical models or machine learning. Okay, so whenever you want to do a higher analysis or in-depth analysis, right, which we call it as machine learning or predictive model, you have statistical models, right, like probability and all that, right? So if you want to apply, first you have to do this. This is very important, and this will also help you understand data. Okay, so whatever the data that you are working, okay, it will help you to understand, identify structures, then types, missing values. Okay, I'll give you all this importance, all this in detail when we are working with a sample data. Okay, so this is just an introduction. So so what we're gonna do is we're gonna do a hands-on also from tomorrow, not today, tomorrow. Okay, so we'll see what is EDA. Okay, we'll see EDA, then we'll see the use cases and what is the importance in data science, the role of EDA, and then we'll see how EDA is useful in data science projects, and we'll see the structured process. Okay, when I say structured process for performing EDA, you have to follow a step by step. Okay, step by step uh, steps we have to follow to perform EDA. Okay, so introduction to data analysis, then EDA techniques and tools, and we'll also see the advanced EDA methods. Okay, so this is the definition. So why do we need EDA? Okay, EDA is a process, or EDA refers to the process of analyzing data sets. Okay, so what we are analyzing here, data set, whatever the data you have. Okay, it could be categorical data. You have 10 columns, all are categorical. Okay, and you have another data set where all columns are numeric. Okay, so what that means is all rows refers to the numeric data type. Okay, and what is the purpose? To summarize their main characteristics. Okay, to summarize their main characteristics. Okay, using, often we use visual methods. Okay, we have already learned Seaborn, then we have learned other Matplotlib, right? So what do we do with these two libraries? To summarize visual methods. Okay, and when we have a visual methods or a visual pictorial form of your data, right, it will give you a good insights. Okay, and also formulate hypothesis. Okay, and what is the importance of data science? Okay, EDA. What is the importance of EDA in data science? Okay, it plays, like I said at the definition, it plays a crucial role, okay, in data science, and it helps in identifying patterns, spotting anomalies. Now what is anomalies? Okay, I already mentioned in the previous classes, right? Outliers. Okay, I'll give you all those examples. Okay, as we uh, go with our examples, right? While practicing, I'll give you all those example anomalies. Okay, sometimes we call it as outliers. Okay, and checking assumption. Okay, and which will help us guiding the data preparation process and the model selection. Okay, so there are predefined models are there. We will learn all those things in machine learning, like supervised, unsupervised, reinforcement learning. Okay, so you need to know the importance of all these things so that you can apply on your data those models and get the prediction. Okay, I'll move to the next slide. Okay, so we'll learn about the data types and structures. Okay, like I said, data is very important. Okay, types, especially data types. Okay, example, numerical, categorical. Like I said, there might be instance where your entire data revolves around categorical. Okay, you don't have a numeric. If you don't have numeric, what is the disadvantage here? So the statistical imputation you cannot perform because it need a numeric data. We learned about continuous data, discrete data, right? Ordinal data, right? All these things we have learned are basics, so it will help you if you have the correct data type and structures. Okay, if you have numerical, you can apply all those machine learning, statistical, then EDA. Okay, I'm not saying you cannot do for categorical, you can do that. There are some techniques, okay, where you have to do where you have to convert a categorical. Okay, you have to convert a categorical data into a numeric data. Okay, and when we talk about the data structures, we have learned about arrays, data frames. Okay, sometimes in real time your data will be unstructured or in array form. Okay, if you have an array form in a single line, okay, you have to convert that data into a data frame. Okay, simple. What is data frame? Data frame, when your data is arranged in a form of rows and columns. Okay, sometimes you will not have a column name also, right? Then you can assign a column name. Okay, and these two types, data types and structure, is essential, okay, for performing EDA. Okay, and we'll also understand the data distribution. Okay, so we have already seen a data distribution with the skewness. We learned about a bell curve. Okay, where your data is skewed on the left, right. Okay, how to treat those inference, or how to come out of the inference based on that data. Okay, so we'll also learn about data distribution. Okay, so what does it do? It allows for insights into the behavior of data points, including skewness and kurtosis, okay, which are vital for interpreting the results. Okay, so I mean, if you see the data and if you make a total or sales, how much we made, that is not what we're gonna do. Okay, we have to apply some statistical test. Okay, what is the future? Are we gonna get something similar number in the future, or it gonna be more or less? Okay, you have to predict. Okay, so that's about the definition about EDA. Okay, why it is important, how you're going to use, and all that we'll see when we get some hands-on. Okay, now we'll see techniques and tools. Okay, some of the common some of the common techniques that I can think of is visualization. Okay, like bar charts, histograms, scatter plot, box plot. Okay, so which will reveal patterns, trends, okay, and the distribution in data sets. Okay, so even if you have a left skew or right skew, right, easily you can make it out that there are some outliers. You have to fix your data first. Okay, now we'll see the tools. Okay, so what are the tools that are available? Okay, so popular tools like Tableau, Power BI, okay, and Matplotlib. Okay, Matplotlib offers, you see, Matplotlib sits on top of Seaborn. Okay, if you see, if you're using 10 lines of statement Python commands to get one visualization in Matplotlib, you have to just use 2 lines. Okay, so that is the beauty of Matplotlib. And if you compare Tableau and Power BI, there are very rich visualization that you can find in these two tools. Okay, and what these offers is a robust features to create interactive and static visualization. What do you mean by interactive? Interactive means you'll be provided with a control there next to your image. So if you want to see these sales, see, for example, right now it is depicting only for Jan, Feb, March. Okay, everybody knows we have 4 quarters, right? So if you want to see the next quarter, what you'll do is there will be a slider. If you just move towards right, it will go to the next quarter, something like that. Okay, so interactive is what, where user can interact with the visualization. Okay, and we called another one is called dynamic visualization. Dynamic is that keeps on changing every now and then. Okay, so for example, your ticket status, okay, how many ticket were added into your queue, okay, 10 minutes ago, 20 minutes ago, so you can see a visualization there with the numbers, right? Similar, one classic example is your share data. Okay, so right, BSC index and all, it keeps on changing, and you get a live streaming there with the chart. So, okay, which share prices are going up, which share prices are coming down. You can clearly see, and what is our total index? You can see up and down. Okay, plus or minus. That those are called dynamic visualization. Okay, so, and these caters to various user experience levels and requirement. Okay, so what that means is you can use these type of charts based on data visualization based on your requirement. Okay. Now we'll see, also we're going to see in EDA, descriptive statistics. Okay. Now we have learned the basics about the central tendency, mean, mode, median, right? But here we will apply those statistical models here and try to understand what our data is telling, what your data is whispering. Okay. Because if you know what it is saying, right, based on that you can take a right decision. Okay, and also we'll see measure of variability. So measure of total tendency such as mean, mode, median summarizes our data by identifying a central point, okay, helping to understand and understand the general behavior of the data. Okay, on the right hand side, on the other hand, measure of variability, it includes range. What is your data range? Okay, so if you say uh, there is a sports data, okay, and there is a javelin statistics are shared with you. Okay, so javelin everybody knows, right? You have a stake that you have to throw it. Okay, by various country or various players. Okay, you have the data set. Okay, if you see, if you want to see the range, right? What was the initial range? Later on, what was the range? Okay, it will help you to measure those data sets. Okay, and show you the improvement, how these sportsmen are improving. Okay, in terms of their practice and when they are going live. Okay, so variance and standard deviation we have already seen, which quantifies. Okay, what it does is it shows or it quantifies the spread of your data points. Okay, we call it a dispersion. Okay, so which will help to assessing data consistency and reliability. Okay, that is why we use this descriptive statistics. Okay, most of the time I'll tell you when we are doing some sample hands-on, right? I'll tell you measure of central tendency, then a measure of variability. Okay, how we are using all these things. Okay, now we'll get into the advanced EDA methods. Okay, in advance what we gonna learn? Correlation. Okay, and covariance. Okay, now if you see here, correlation and covariance, okay, are statistical tools that helps in assessing the strength and direction of relationship between two variables. Okay, here we are talking about two variables. What are those two variables? For example, you have a student data set, okay, which is in the form of rows and columns. Okay, now what do you mean by variables here? Okay, variables denotes your columns. Okay, for example, you have how many hours students are practicing, okay, and score. Okay, now if you see the relationship between number of hours studying versus your scores. Okay, so if you have these two data type, okay, these are, I'll say these are the two variables that I can see there is a relationship. Okay, correlation and variance are statistical tools that help in assessing the strength and direction of relationship between two variables. Okay, and it provides insights into how they influence each other. Okay, this is very important, influence word. Okay, how they influence each other. Okay, now I'll take one classic example is marketing and sales. Okay, you have a marketing and sales data. Okay, you have various uh, columns there, and you have one column called marketing spend. Okay, and sales. Okay, when you spend more money on your marketing methods or techniques, right, you can see improved sales, right, target, or you'll achieve, or you can achieve or overachieve your targets. Okay, so and also we'll see about the visualizing correlation. Okay, so there are some charts that are available tools, okay, like scatter plots, okay, heat maps, okay. These are all you can call it as a visual tools also, okay, just like a plotting and all, okay. But this has a different understanding and usage for scatter plots and heat maps, okay. So which will help us to understand the correlation by presenting data in a way that highlights the relationship, making pattern easier. Okay, so these are all the topics. Okay, another interesting topic that you will learn is handling missing data. Okay, so this is very core of EDA. Okay, so what are the techniques for imputation? Okay, now here you see you're gonna use central tendency. Okay, mean median mode. Okay, and what it does, it helps fill in missing data points, allowing for more complete data set that can be effectively analyzed. Okay, midpoint, okay, midpoint, median, okay, and more. Okay, if you do it practice, then you will get some hands on. Okay, if you don't do it, you will not get any idea about how to use this measure of central tendency. Okay, and how does it impact handling missing values? Okay, see, if you have a missing value, okay, for example, you have a student score, okay, which has some 5 columns and some 100 student details are there. If you have some missing values, okay, in the student data set, okay, what it will do is, okay, when you distribute the data, right, you will see some skew results, okay, which will lead to inaccurate conclusion. Okay, so you will see when you for example, sometimes what happens is missing value. When we say missing value, okay, there could be a genuine value. Okay, now the example that I gave you, student data set, okay, could be that student was on a medical emergency. Okay, so he didn't attend those exams. Okay, it could be a genuine reason also, but you need to give a proper comment to the row. Okay, for example, instead of leaving it blank, you can put zero. Okay, and you can create a legend separately for zero is um absent or medical leave, something like that. Okay, so that we can infer, okay, when we are getting the results out of that data sets, right, it will clearly, we can clearly understand what we need to do next. Okay, handling missing value. Okay, there are others also. Okay, like I said, patterns, trends, relationship, anomalies, okay, insights. So these all play an important role in EDA. Okay, so and EDA is the first step. Okay, after you collect your data, you have to perform EDA before applying statistical models or machine learning, which are advanced models. Okay, and why EDA is important, I already explained you, right? So understand your data, detect errors and outliers. Okay, spot inconsistencies, mistakes. Okay, and feature selection. Okay, you will also learn about feature engineering. Okay, feature, FEATURE, feature engineering. What is it? Decides which variable matters. For example, you have a data set where you have uh, a columns close to 20 columns. Okay, but the analysis or the project that you're working on, you just require 10 columns, not 20. Okay, that is called feature engineering, where you will decide which columns or variables matters for your analysis. Rest you will drop it. Okay, rest you will say Python except these columns, drop other columns which I don't need. Okay, so that you can see your data clearly. Okay, model preparation. Okay, then you will do something called model preparation. Okay, like scaling, encoding. Okay, what is encoding? For example, I give you an example of converting a categorical data to numeric data. For example, you have a gender. Okay, for example, I'll go to data set. Okay, I'll pick something education classification NLP data we have pre-trained all data set. Uber data. Okay. Netflix movie and TV show. Okay. So this is the data set. Okay. Now you see here show ID. Okay. And then you have type, title, director, cast, country. Okay. Duration, rating, and release year, and blah blah blah. You have all those information here, right? Now, if I want to do a rating system, okay, so I have this many columns. So what are the things that I might require? I might require duration, rating. Okay, now duration and rating. Think about these two columns. Okay, if a duration is less, do you think the rating will be good? Sometimes maybe yes, maybe no. Okay, so it's a neutral. Okay, if your duration of the movie or the film that you are creating, right? If it is for 1 hour, you might get a different rating, right? If it is 2 hours, you might get a different rating based on the content. If the content is very interesting and all that, okay, you might get a good rating. Okay, so you can see what is the rating they are giving. Rating means TV rating of the movie show. Okay, now here you see PG, parental guidance 13. Okay, TVMA. Okay, TVMA. Even I'm not sure. Okay, TV rating for movie. TVMA. Okay, so what we have to do is, if you don't know what is the TVMA means, you have to get into dictionary, data dictionary. Okay, so let me check if they have given a TVMA. Okay, so data dictionary is not there, guys. Okay, so first thing is, first you need to have a data dictionary. Okay, let me check if I have something. Okay, let me go to rating. Okay, so rating, TV rating, movie show, TVMA. Okay, MA, TV 14. Okay, these are the channel names maybe. Okay, channel names. Okay, so unique only 17% is there. Valid is 100%. Mismatch is 0, and missing data is 4. Okay, out of how many rows? We can check here how many rows we have. Okay, 12 columns. Uh, So this data, I don't think so it is correct. Okay, but anyway, this is just for an example I want to show you. So what is important here when you get a data? Okay, so the data dictionary is very important, which helps you define or describe your data. Okay, so if you have something here, TV show, movie, TV show, movie, okay, you need to understand type. Okay, so definition of type, what all it includes. Okay, so this is just an example I want to show you. Uh, Let me pick up some interesting data. Okay, so that you can understand basics. Today we're going to do only basics. Okay, Titanic, machine learning from disaster, house prices, spaceship Titanic. Okay, LLM classification. Okay, I'll just pick up for now this one. Okay, nothing is there. Then go to competition. Okay. Anyway, when we get into this EDA, right? I'll go through step by step. Okay. Right now, I mean, when I was using this Kaggle for especially for data sets, okay, to download, so you'll get a data dictionary. Okay. So let me just type here and see if I get some clue here. Data dictionary. Okay. Comment on data dictionary. Yeah, I got one. I'll just go through it. Okay, now you see this guy has created IMP Varex. Okay, this is a column name. Okay, and what it means is amount for the bank office. Okay, so this is called a proper uh, data dictionary. Okay, data dictionary describes about the columns, what it does, why the values are in numeric. Okay, if you see a mismatch with your data type, then you have to correct that also. Okay, so it's a very simple, but you're gonna learn a lot here. Okay, a lot. I'll go and search one more data dictionary. Okay, so this is the same only. So I'll go to data. So I have some data here, train test, some samples.csv file. Okay, and okay, now you can see these are all dynamic. So whenever you click on anything, your data keeps on moving. You can see here. Okay, so you can create your dashboards also in Python. Okay, but what we're gonna look at is data dictionary. Okay, I want to show you one example. Ah, see, this is what I was looking for, data schema. Okay, so the data contains the following columns. Okay, these are column names you have in CSV file. Okay, what is a date? Date of the booking. We know date. Okay, but we don't know what date that denotes to. Okay, date of booking. So what data type is this? Uber data analytic dashboard. Okay, so Uber cars, you know, right? Bike and all. So you book, date of booking. Okay, it picks up from your system the day you are opening the app and you are looking for a cab or some vehicle for your ride. Okay, time of the booking, booking ID. So if you gave all these meaningful names like this, right? So even if you don't know about the data, by going through, you will understand what that means. Okay, now you see customer rating. Okay, now this is a rating. Okay, 1 to 5 scale. Okay, so you will see in each of the rows, you will see 1, 3, 6, sorry, 5, 4, 2, 1 repeated. Okay, why? Because this is a ordinal data. Okay, so scaling 1 to 5. This is also ordinal data. Okay, driver rating. After the ride is done, the driver will ask you, request you, sir, you will get a shortly you will get a SMS for rating. Please rate me good. Okay, you might have seen same thing in Swiggy data also. Okay, in the app you get. So this is a ordinal data type. Okay, now ride distance covered during the ride in kilometer. Okay, so if you are going for 10 kilometer, it will go through 1 2 3 4 5 6 7 8 9 10 10 kilometer, right? What is that data type? Okay, continuous data. Okay, booking value. Okay, booking value doesn't change. It's a, it could be a float, it could be a integer. Okay, so called this is called a data dictionary. Okay, this is very important, guys. Okay, if you don't understand columns, there is no point of doing your analysis. Even your current job, whatever data, see, everybody plays with data. Okay, if you don't have understanding about the columns, okay, so if you don't know, you have to ask the owner of the data. Okay, whoever is the owner for that data, go back to him, ask him, question him, what does this column means? What does this column means? Okay. Okay, guys, so this is about the basics. Okay, just an introduction. Okay, so tomorrow we're gonna do some more hands-on with basics. Okay, so I'll pick up some data. We'll do some Seaborn library analysis. Okay, you know Seaborn has a lot of data sets that you can play around. Okay, with Titanic, Iris, you might have seen all those data sets, right? So we will play around with those data sets to understand our data patterns and other techniques. Okay, so what we'll do is we'll close this session for today. It's gonna be very short. Okay, so we have another 10 minutes. I'll give it back to you. Okay, so you can stop the recording, Sahib.